So we want to solve this quadratic inequality. Again, think of it like a quadratic equation. If you were solving a quadratic equation, the very first thing you would do is make one side equal to 0. So I would just subtract 1 on both sides so that I have it equal to 0. And then I get 3x squared plus 2x minus 1 is less than 0. Once I have that, if we can, okay, we're going to imagine it's equal to 0 and we're going to factor this. Well, if it's 3x squared, it'd have to be 3x and x. If the last number is 1, it would have to be 1 and 1. This one's actually pretty easy to factor if it works. Now you just have to decide what's going to be positive, what's going to be negative. You need a negative 1, so 1 will have to be positive, 1 will be negative. Can you see that I'll need this one positive, so my outsides make positive 3x. My inside makes minus 1x, which makes 2x. And then my solutions, or my x-intercepts, or my critical points, or my roots, or my zeros, there we go, I think I hit them all, will be 1/3 and negative 1. So now we imagine our number line. Imagine a number line. Of course, negative 1 would be to the left of 1/3. This is where 0 would be on our number line, somewhere in between there. And we need to find out what sections are true, what sections are false. We know that our x-intercepts are here at negative 1 and 1/3, and because our original equation has a less than 0 sign, when we put them in, we would use open circles at those values because they're not included in our solution. Negative 1 and 1/3, if you plug them in, would make it equal to 0, and 0 is not less than 0. Now, if we look at the quadratic function that we're thinking of, if we think of the parabola, y equals 3x squared plus 2x minus 1, would that open up or would it open down? It would open up. So if we imagine that parabola, it would look like this.
If it was like 3x squared plus 2x divided by 1 less than or equal to 0, then it would be closed.
Then they would be closed circles. So if it was less than or equal to 0, then those would become part of the solution because that's where it's equal to 0. So now we're looking for where is it less than 0. If we look at our first section, is it less than 0 in our first section? No. Is it less than 0 in this section? Yes. Is it less than 0 in this section? No. Can you kind of see that this part, the 0 part, is taking place of the y in your quadratic function? So when you're asking if it's less than 0, you're really asking, are your y values less than 0? And if your y values are less than 0, they're below the x-axis. Y values being greater than 0 are where it's above the x-axis. So we could see from the graph that it had to be false, true, false, and so our solution would be right here on our number line between negative 1 and 3, and we could write that and these would not have equal signs because we have open circles where x is a real number. Or in interval notation, you would use round brackets for your solution from negative 1 to 3. So it's a preference thing. Maybe you like interval notation or set notation better. Maybe one makes more sense to you. Maybe you want to become a true mathematician, which means you like to write things in as least amount of space as possible. So then the interval notation takes less room to write because there's less symbols to write. Who knows? But those are your preferences. So here's the solution on the number line, and that is how you would write your solution in both set notation and interval notation. So the questions you can do for practice for this one are 4, 5, and 6.